In this video, we're going to learn how to graph quadratics in standard form. Standard form for a quadratic function looks like this. F of x, or y, equals ax squared plus bx plus c, where a is the coefficient of the x squared term, b is the coefficient of the x term, and c is the constant. The graph of a quadratic function is a U-shaped figure known as a parabola. If the a value in our quadratic function is positive, then that parabola will open up as I've drawn it here. However, if that a value is negative, then the parabola opens down. If the parabola opens up, we say it is concave up. If it opens down, we say it is concave down. The low point or high point on our parabola is called the vertex. If our parabola is concave up, then the vertex is a minimum point. If our parabola is concave down, then the vertex is a maximum point. When we graph parabolas in standard form, the first thing we will locate is the vertex. The x-coordinate of the vertex can be found by using the equation x equals negative b over 2a. Once we find the x-coordinate, we'll simply plug that in to find the corresponding y-coordinate. The next point on the graph we want to locate is the y-intercept. The y-intercept of a graph is always found where the x value is 0. So if we were to take a 0 and plug it in for the x here and here, the resulting value would be c. So the y-intercept will always be found at the point 0, c. Let's look at an example. Consider the quadratic equation y equals 2x squared minus 8x plus 6. To graph this equation, we're going to begin by identifying a, b, and c. A is the coefficient of the x squared term, so that would be 2. B is the coefficient of the x term, so that would be negative 8. And c is the constant. So for this problem, that is 6. Now let's find the vertex. Recall that the x-coordinate of the vertex can be found by solving the equation x equals negative b over 2a. In this problem, b is negative 8 and a is 2. So plugging those in, we get 8 over 2 times 2, which simplifies to 2. To find the y-coordinate that goes with that, we take this 2 and plug it back into the equation for the x. So y becomes 2 times 2 squared minus 8 times 2 plus 6. You can plug that in your calculator and find the value, which is negative 2, or you can just figure it out in your head. If you're figuring it out in your head, be sure you perform your order of operations correctly. Be sure you square the 2 and get a 4, then multiply by 2 for an 8. Don't multiply first and say 2 times 2 is 4 and square that and get a 16. That will give you the incorrect answer. Now we want to take the x and the y and put them together to come up with our vertex, which is the ordered pair 2, -2. Because our a value is positive, we know this parabola will be concave up. So our vertex is going to be a minimum value. Let's go ahead and plot that point on our graph. Parabolas are symmetrical, so we can draw a vertical line through that vertex. This is called the axis of symmetry, and the parabola will be symmetrical about that line. So our axis of symmetry is the vertical line x equals 2. Recall that the c value of the equation tells us where our graph crosses the y-axis. So our y-intercept is the point 0, 6. Let's go ahead and plot that point on our graph. We can use symmetry to find a third point on our parabola. There are 2 units from our y-intercept to our axis of symmetry, so we can go 2 units on the other side of the axis of symmetry and plot a third point. 3 points determine a parabola, so we can connect those 3 points with a smooth curve. And there is the graph for the equation y equals 2x squared minus 8x plus 6. You can see that this parabola is getting wider as we move to the left and as we move to the right. So the domain is going to be the set of all real numbers. The range is controlled by the vertex. All the y values in this graph are greater than the y value of the vertex, which is -2. So our range is y is greater than or equal to -2. On your homework, you're also asked to describe the end behavior. This parabola is concave up, so both ends are going up. And that completes the problem. Let's look at another example. Consider the quadratic function f of x equals -3x squared minus 6x. In this problem, the coefficient for the x squared term is -3, so that is the a value. The coefficient for the x term is -6, so that is the b value. And there is no constant, so the c value in this problem is 0. To find the x coordinate of the vertex, we solve the equation x equals -b over 2a. For this problem, -b would be +6, and 2 times a would be 2 times -3. That simplifies to -1. To find the y value of the vertex, we take this -1 and plug it back into our original equation for the x. When we do that, we see that f of -1 is -3 times -1 squared minus 6 times -1. Plug that into your calculator or do the computations in your head, and we find that the y value is 3. Now we want to take that x coordinate and that y coordinate and put them together to come up with the ordered pair for our vertex, which will be the point -1, 3. Because our a value was negative, we know that this parabola is going to be concave down, so that vertex is going to be a maximum point. Let's go ahead and plot that point on our graph. Now we can draw our axis of symmetry through our vertex. So our axis of symmetry becomes the line x equals -1. Because the c value in this equation was 0, our y-intercept is going to be the point 0, 0. So let's go ahead and plot our y-intercept on our graph. And then using symmetry, we can bounce that point across the axis of symmetry and get our third point. 3 points is enough to determine a parabola. So we'll connect those 3 points with a smooth curve. And there is our parabola. This parabola, like all parabolas, gets wider as we move to the left and as we move to the right. So the domain is going to be the set of all real numbers. Unless we make some restrictions on the domain, for parabolas, that domain will always be the set of all real numbers. The range is controlled by the vertex. All the y values in this parabola are below the vertex. And in this parabola, the y value of the vertex is 3. So our range becomes y is less than or equal to 3. This parabola is concave down. So for our end behavior, we just need to state that the ends go down on both sides. And that completes the problem. For our last example, we're going to look at graphing a quadratic inequality. You can see that the equal sign has been replaced with the greater than symbol here. We begin by identifying a, b, and c. The coefficient to the x squared term here is an implied 1, so a is equal to 1. The coefficient to the x term is -2, that becomes our b, and the constant is -3, so c will be equal to -3. Next, we find the vertex. Once again, the x-coordinate can be found by solving the equation -b over 2a. For this problem, -b would be +2 and a would be 1. We plug those in and simplify and come up with our x-coordinate, which is 1. To find the y-coordinate, we take this 1, plug it into our original equation for the x's. That gives us 1 squared minus 2 times 1 minus 3. We simplify that for -4. Now we're going to take the x and y coordinates and put them together to find the ordered pair for our vertex, which is the point 1, -4. Let's go ahead and plot that point on our graph. We can draw in our axis of symmetry. And now we're ready to find our y-intercept. Recall that the c value tells us where we cross the y-axis. So we know we're going to be crossing the y-axis at -3. We can just go ahead and put that point on our graph. We're going to count down 1, 2, 3, put a point, reflect that across our axis of symmetry. Now we have 3 points. That is enough to determine a parabola. But this is where the inequality becomes different than graphing just an equality. When graphing inequalities, the inequality symbol determines what kind of a line we use to connect our points. If we have a greater than or less than symbol, we will use a dashed line to connect our points. If we have a greater than or equal to or less than or equal to symbol, we will use a solid line to connect our points. You can see that in our problem, we have a strict inequality, a greater than symbol. So we're going to be using a dashed line to connect our points. The final step in graphing a quadratic inequality is to determine whether we need to shade inside or outside the parabola. To do this, we choose a test point. We can choose any point we want as long as it does not lie on the line that defines the parabola. I'm going to use the point 0, 0. I chose this point because I'm going to have to plug these coordinates back into my original inequality, and zeros are easy numbers to plug in. So I'm going to go back to my original inequality now and plug in 0 for all the x's and 0 for all the y's. So I'm going to come up here and put in a 0 for this y, a 0 for this x, and a 0 for this x. When I do that, I come up with 0 is greater than 0 squared minus 2 times 0 minus 3. Simplifying that, I come up with 0 is greater than negative 3. That's a true statement. So the point 0, 0 has to be part of my solution set. If that point is part of my solution set and it lies inside the parabola, then all other points that lie inside the parabola are also part of my solution set. So I'm going to shade all of the points inside my parabola, and that becomes the solution to this problem. Now, had I come up with a statement down here that was false, I would have shaded the region where the test point did not lie. So I would have shaded outside the parabola instead of inside the parabola. And that concludes this lesson on graphing quadratic equations and inequalities.